Hello guys, today I want to solve a logarithmic equation using the examples that you can see here on the board. Using this particular example, there are five good examples, and most of these questions here are objective. So it is assumed that you would have known how to solve a questions like this before you take your examination, whatever examination you're supposed to take. So for those of you that have not subscribed to my channel, I'm saying please hit that subscription button for you to get great content like this and more. So let's jump right into it. Like you can see, now in this particular video, I'll be applying some of the laws of logarithm to solving most of these questions. So stay tuned and see how it goes. Now you'll be wondering, you'll be saying, yes, that I know how to solve this question. I know how to solve this question. So what of this question number four? What of question number four? Question number four is a bit tricky. Now, if you actually want to know how to solve question number four, you stay till the end of this video. See you. Let's jump right into it. Now, the first question is the log of y to the power of half base 2 is equal to log 125 base 5. That note that 125 is something as 5 times 5 times 5, which is also the same thing as what 5 to the power of 3. I like to very bold like this. Yes, and also that the power law of log. Also note that the power law of log says if you have log x to the power of n, right? Now that can be written in this form. The power goes to the back of the log, and you have n log x. Also, if you have something like this, you can write it like this, meaning that uh, the number at the back of the log can be taken as the power of the the log of that particular number. So meaning you can rewrite this as what? The log of x to the power of n. So if I have a question like this, we can write it like this. Also, if I have a question like this, we can write it like this too. Yes. So let's jump right into it. We have log base 2 y to the power of half to be equal to the log of 5 to the power of 3 base 5. Okay. So this now becomes log base 2 y to the power of what? Half is equal to, if 3 goes to the back of what? The log, we have 3 log 5 base 5. Now mind you, log a base a is equal to 1. Log a base a is equal to 1. Log a base a equal to 1, meaning if you have log 100 base 100 is 1. Log 5 base 5 is 1. Log 3 base 3 is 1. Log 20 base 20 is 1. Log 10 base 10 is 1. So this now becomes the log of y to the power of 2, 1 over 2 base 2 is equal to what? 3. So because this is what? Log 5 base 5 is what? 1. 1 times 3 is 3. So that's why I'm writing 3 direct. So applying the definition of log, right, such that we change log to what? Indices. According to the definition, the definition said the base raised the power up. So the base is going to raise this power up. So that means we're doing a transformation from log to what? Indices now. So I'll write it this side. So this now becomes y to the power of half is equal to what? 2 to the power of what? 3. So the base raising the power up. So the number here, 3 here is the power. This is what the base, and the log is what? Y to the power of what? Half, or 1 over 2. Alright. So this is now what? 2 to the power of 3 is the same thing as 2 times 2 times 2, which is equal to what? 8. Right? So this is 8. So our y to the power of what? 1 over 2. So how do we find exactly the value of what? Y? We're looking for y, not y to the power of 1 over 2. So what we're going to do is what? We multiply multiply the power by 2. Now you can use other means, right? You can use other means um because the y to the power of 1 over 2 is the same thing as the root of 2 of y. The same thing as the root of y. So you can just have something like this, right? And just say square both sides. Yes. So since I said I'm multiplying the power by 2, so this is now y to the power of 1 over 2 times what 2 is equal to. Note that when the value is written like this, the power is 1. So 8 has the power of 1. So we now have 8 raised to the power of 1 times what 2. So this is what y equal to. Now 1 times 2 is what 2. 2 divided by 2 is 1. So y to the power of 1 is equal to 8 to the power of 2. And 8 to the power of 2 is 8 times 8, which is the same thing as what? 64. So this ends this particular one. So if you have any question to what I just did, you can just drop it in the comment section. Or if you have a contribution, if you have a more easier way to solve this particular question, yeah, nobody's an island. I tell you the truth, nobody is an island. I want to learn from you guys too. You can just quickly drop it in the comment section. Thank you. So let's move to the next question. So this is the next question. The next question said that if log x minus y base 3 is equal to what? And log 2x plus y base 3 is equal to what? To find the value of x only. So we're dealing with the value of x only. So I'm going to write them out. So we have the log base 3 of x minus y equal to 1. That's the first one. Then we have log base 3 of 2x plus y is equal to 2. Now, so if I use the definition of log to raise this particular power up, as if the base raise the power up, likewise this one, raising this power up, what we're going to have is, this now implies, what we're going to have is, we're going to have x minus y equal to what? 3 to the power of 1. Likewise here, what we're going to have is, we're going to have 2x plus y, 3 to the power of what? 2. Beautiful. So let me rewrite them here. So that means we have x minus y equal to what? 3. So we call this equation 1. And we finally have 2x plus y equal to what? 9. Let's call this equation 2. Alright. So now, if you look at this question, if you look at what we've done, it has now taken us back to what? It has led us towards simultaneous equation. So now, simultaneous equation has what? Two methods of solving, right? So in this particular question, I advise you solve using what? The elimination method. The reason is that if you look at the two terms there, right, we have x and what? Y. Now the y term has a minus sign in the first equation. The y term in the second equation has plus sign, right? Such that if you have your minus sign plus the other one, it's going to give you what? 0. So what I mean is this. I mean, you have minus y plus what? Y. This gives us what? 0. If you are using what? Elimination method. So now, using elimination method, so we have x minus y to be equal to 3. Then we have 2x plus y equal to what? 9. So we add two equations plus. So x here, positive x plus positive 2x, x plus 2x is what? 3x. Now minus y plus y, remember I said it's 0, so we ignore that part. Now 3 plus 9. 3 plus 9 is just 12. So we have 12 there. Divide both side by 3. Divide both side by 3. Finally, if you cancel this and cancel this, so x is equal to what? 4. So that is that. So now, since the question said find the value of x only, we've done that. Now, predictively, if you are to If you have to find the value of y, how do you do it? So simple, right? From this first part, from this equation one, you can just fix y there. That means when you represent what when you replace x with what the value of what x there, which is 4. So you have 4 minus y equal to what 3. So you can see how it goes, right? 4 minus y equal to 3. So if 4 goes to the other side, go and meet 3. We have minus y equal to what 3 minus what 4. And 3 minus 4 is what minus 1. Right? So we have a minus on y, we have minus on 1. The minus cancel themselves. Y is equal to what 1. So if you have to solve for y, so that's how you go about it. So thank you guys for watching this particular part. Also, if you're not subscribed, just hit that subscription button. And like I said, if you have a better way to solving this particular question, you can just um, drop it in the comment section so that others would also learn from you. Nobody's an island of knowledge. Thank you. Let's move to the next question. Beautiful. Now, I like this particular question very well. Right. So the question is open bracket the log of m base 2 all to the power of 2 minus the log of m to the power of 3 base 2 equal to what 10. All right, that's nice. So the first thing we're going to do is what? Move this power to the back of what? This log. That's the first thing. So this is now the log of what? M base 2 to the power of what? 2 minus 3. The log of m base 2 is equal to what? 10. Nice. Now, it looks somehow again, right? So the question is, what do you do and all that? How do you now? If you have a question like this, define log m base 2, right? So the definition is we just say let log m base 2, let it be a value, let it be a, right? Just let it be a, such that, so since this one has a power, right? So this now becomes what? A squared minus, this is what? Log m base 2 multiplied by 3. So this now becomes what? 3a, and is equal to what? 10, just like what we had here, right? Great. Now, um, this looks more like a quadratic equation. But in quadratic equation, our constant part in quadratic equation, the other part, that's the right hand side, is always 0, right? So we're going to move 10 to, we're going to move 10 toward the left hand side to join the equation. So we have a squared minus 3a. Notice something, that 10 is what? Positive at the right hand side. So moving it to the left hand side, it becomes what? Negative. So that we have 0 at the right hand side. All right. Now I like this quadratic equation. This is now quadratic equation. I like this quadratic equation because um there's no coefficient of x squared, so it makes it more easy. So the question is, what are the two numbers you multiply to get the constant? The numbers are 2 and 5, right? 2 times 5 is equal to 10. Great. But since we have negative here and negative here, we'll consider the fact that the highest factor of 10 carries the negative sign. So that means we have minus 5 times what 2 to give us what? Minus 10. And also minus 5 plus 2 to give us what? Minus 3. That's nice. Great. So that means that the factorization of this particular expression is just basically um, we have a plus 2 in bracket, which is, you can see I'm using 2 here, and I want to use 5 in the second bracket. A plus 2, and the second bracket is a plus 5 equal to 0. Great. So since we have this one now, it then means that the brackets are both equal to 0. So the first bracket is equal to 0, or the second bracket is also equal to 0, right? So if you take 2 to the other side, to the right hand side, so it becomes a equal to minus 2, or a is equal to what? Oops, I wrote plus here. Sorry about that. Ah, my bad. So this is what? Plus 5. Great. Now, don't forget that your a is what? Log m. So we're looking for the value of what? M. So recall that a is what? Log m base 2. So since a is log m base 2, I'm replacing a with what? Log m base 2 to be equal to what I have as the value of a, or log m base 2 is equal to what? 5. Great. So applying the definition of log to flip the word indices such that you get the value of m, right? Now this now becomes what? M equal to this base raise this power up. So we have 2 to the power of what? Minus 2. Or we have m as what? 2 to the power of 5. Great. Now 2 to the power of minus 2. This is the same thing as 1 over 2 raised to the power of 2, which is equal to 1 over what? 4. Or now this is what? Now 2 2 in what? 5 places, meaning 2 times 2 times 2 times 2 in 5 places gives you what? M as 32. So this is how to solve this question. This is how to solve this question. Like I said, like I always say, if you have a better way to solving the question, you can drop it in the comment section, so that we all learn. So I started by what? Moving the power here to the back of the log. That's why we got 3 log m base 2. And we have a 10 here, which is part of the question. So we defined, the reason why we defined it is because we have log m base 2 in bracket here and squared. And there's another log m base 2 here. So this looks exactly like a quadratic expression, but in logarithmic form, right? In logarithmic form. So by definition, by giving the logs a unique definition, right, to reduce the particular expression, it makes the entire work more less stressful. Yes. So we have the entire equation looking like a squared minus 3a equal to what? 10. Right. So we now factorize here. Factorizing here. So by factorization, what I just did was, since the first term does not have a coefficient, or the coefficient of the first term is just 1, right? We focus more on the constant term. So at the constant term, the numbers we multiply to get the constant, which is 10 here, is 2 and 5. Right? But note that we have negative sign here, negative sign here. Right? So that means one of the factor, the highest factor of this constant term, has or carries the negative sign. The highest factors carry negative sign. So the least factor is positive. So we have minus 5 times 2 to give us minus 10. Then minus 5 plus 2 to give us a minus 2. So that means we're looking at what? Minus 5 and plus 2. So it's as simple as just opening the bracket and writing a plus what? 2 as the first factor, a minus 1 5 as the second factor. You can check that at home. You can just carry a pen and paper and just try to open this bracket to see if you're going to get what? As they call minus 3a and minus 10. So finally, we now have that the individual bracket equating to give you what? 0. We have a plus 2 equal to 0, or a minus 5 equal to 0. And we already know what a is. So we brought back the definition of a, which is what? Log m base 2. So equate to these individual values. So you can see we don't need a again. We discarded a and just put the definition of a. So thank you guys for watching this part. Let's move to the next question. So this is the final question in this particular video. This is the fifth question. All right. So the first thing I want us to look at in this particular question is this 27. 27 is something as well 3 times 9, right? And you know that 9 is the same thing as well 3 times 3, right? So that means 27 in power form is the same thing as 3 to the power of 3. That's one. Great. Now the second thing I want us to recall in this video is that remember that a to the power of 1 times a to the power of 2 is the same thing as a to the power of what? 1 plus 2 indices to give us a to the power of 3. So up here we have 5, the root of what? 5. So we're going to rewrite this as what? We're going to rewrite this as 5 times 5 to the power of what? 1 over 2, because we know the root is the same thing as 1 over 2. So that means the first 5 has a power of 1. The second one has a power of what? 1 over 2. So Using applying indices here, we'll pick one of the five, right, and add the power. So by adding the power, we have 1 over 1 plus 1 over 2. So if you do this correctly, you're going to get what? 5 to the power of what? 3, 3 over 2. Meaning that the LCM is 2, then you have what? These 2 multiplying this 1 here, 2 times 1 is 2, and this 1 multiplying 1 here. So you're going to have 2 over 2 here plus what? 1, which is what? 2 plus 1 is 3 and over 2. So you have this. Alright. So back to the question. So the question is this. I'm not writing the question. We just go straight into solving. We minimize space and the rest. So instead of writing 27, I'll write what? 3 to the power of 3 minus 3. Now instead of writing this 5 root 5, I'm going to write this because I've explained that already. We have 5 to the power of what? 3 all over 2. Right? Or over. Now remember we have 10 here, and 0.6 is same thing as what? 6 over 10. So I'm going to write that as what? 6 all over 10. That's nice. So if this power leaves this particular part to the back of the log, and this one is moved from here to the power of this number, we're going to have something like this. We're going to have 3 over 2 multiplying over 3, the log of what? 3 minus. So this 3 that is here is the one that is moved from the power of 3 to the back of log. And here, the 3 that is here is moved from this particular part to 3 over 2 here to the power of 3. Yes. So this power here, this one at the back of the log here is moved to the power there. So draw a very nice line. And mind you, here if we reduce this number by 2, we're going to have what? 3 all over what? 5. Nice. 3 over 5. Okay. So let me clean all this. Alright, so multiplying these numbers at the back of this particular log, we're going to get 3 times 3 is what? 9 over 2, the log of what? 3 minus. So this is the same thing as saying we have 5, and if you multiply this, just like the power law of indices state. So 3 multiply 3, there we have 9 over what? 2 also. All divided by what? The log of 3 all over 5. Great. So the next thing is 9 over 2 log 3 minus. Now we move this power, right, to the back of this particular log. So this becomes what? 9 over 2 log what? 5. All divided by what? The log of 3 all over what? 5. 3 all over 5. Good. So what else do we need to do? Mind you, there's a 9 over 2 here. There's another 9 over 2 here. So let's factor out the 9 over 2. So we have 9 over 2. Now put this in bracket. The log of. Now, in log, when you have minus, it means division, right? So we're going to have 3 divided by what? 5 for this log. So I'll put this in bracket. All divided by the log of another 3. The log of what? So the log of 3 over what? 5. So this log here cancel this particular log. So these two cancel themselves. And we have 9 all over what? 2 as our answer. Powers are what? Since the numbers at the back of the log are the same, what we did is what? We just factored and applied the subtraction law of what? Log. Yes, that says when you have two logs subtracting themselves, the product is what? Or the output is what? The log actually dividing themselves. That means log y minus log x. Right? Finally, you have what? Log y over what? X. Yes. So this is the definition of that subtraction law. So Thank you guys for watching. If you're interested in how is it called, a private tutoring, you can send me a private message on my email, or I will drop a particular link where you can get my direct contact and you send me a message. Thank you guys for watching. See you in the next one.